Welcome back. In the last video, we looked at when we put the angle bisectors in different types of triangle, we find that the intersection is always inside the triangle, and it's the center of the circle that's inside the triangle. So we call it the in-center. Okay? I'm going to accentuate that. We call it the in-center, inside the triangle, and it's the center of the circle inside the triangle. Okay? And then we looked at how we can identify them. We need to look for the arc marks to look for an angle bisector. And then what type of information we know. All we know when we have an angle bisector is that we have two congruent angles. Okay? So now let's look at these examples. It says find the measure of angle HSD if the measure of angle 1 is 21.5. So the measure of angle 1 right here is 21.5. And it does tell me in the directions, we always want to read the directions, each triangle has an angle bisector or an in-center shown. So I know that this is an angle bisector because my directions tell me I have one. So if one side is 21.5, the other side is also 21.5. It's asking me to find the measure of angle HSD. So where is HSD? HSD is the whole angle. So the measure of angle HSD, I'm going to use my angle addition postulate to do 21.5 plus 21.5, which is going to give me 43 degrees. Okay? When I look at the next one, and I see the measure of angle, find the measure of angle 1, so I'm looking for this one here. If the measure of angle BTL equals 48 degrees. So BTL, so this whole angle is 48 degrees, which means the measure of angle 1 is going to be half of that because I'm going to divide it into two equal pieces, which is going to be 24 degrees on each side to get my total of 48. So angle 1 is 24 degrees. Okay. All right, the next one, the distance from C to G is 18. So from C to G is 18. And we want to find C to Q. So if I'm looking for C to Q, now notice I have the little right angle there, and I have the little right angle there, and I have the little right angle there. So those are the distances to the side, which means that is where the circle that's inside from my in-center, that's where the circle is going to be touching. Okay? So think about if I were to redraw that circle, and from the center C out to the edge G, think about what we call that distance, right? It's halfway across the circle. We call that the radius. And what do we know about all the radii in the same circle? They're all the same. That one's also a radius, right? And they're all the same length. So if one is 18, that means the other one is also 18. So this piece here is 18, and this one here, C to R, is also 18. All the radii in that circle will all be the same thing. So C to Q will also be 18. We're not sure what kind of units they are, so I'm just going to put units. Okay? All right, let's look at these last two problems down here. C to A is 8. So C to A, well, we know it goes to the 90-degree angle, so if it's 8, we know all the others that go to the 90-degree angles are also 8, right? All right, and then A to J is 15. So A to J is 15. And we're trying to find C to J. C to J, this is what I want to find, is this piece right here. I'm going to put an X on it. Okay? Well, now look at what I know. I know I have 8, I have 15, and I have an X, and I've filled in a little right triangle. So I've made a little right triangle where I've got 8, 15, and I'm trying to find the hypotenuse. I can use the Pythagorean theorem for that. I can do my 2 legs squared added together will equal my hypotenuse squared. A squared plus B squared equals C squared. So 8 squared plus 15 squared is going to equal my C squared. My C is the hypotenuse x. So 8 times 8 is 64. 15 times 15 is 225. That equals x squared. 64 plus 225 is 289. And that equals x squared. I don't want x squared, I want just x, so I'm going to have to square root to unsquare. The square root of 289 is just 17, and that's going to equal over here when I take the square root of x squared, my square and my square root cancel out, and I end up with just x. So c to j x is 17. And we'll just say units. Okay? All right, one more problem. Let's look at this last one. C to Q is 3. C to Q is 3. And that goes to my 90, so that means this one is also 3. And that means this one is also 3. C to E is 10. C to E, this piece here, is 10. And I'm trying to find E to N. E to N. Well, that's just like the last problem, right? I have this little right triangle here with my right angle there. And I know one side is 3. I know one side is 10. And I'm looking for this third side. This is a little bit different because look what happens when I resketch this triangle. I've got my 3 here. I've got my x here. And I've got my 10 here. So when I do a squared plus b squared equals c squared, remember the c, the hypotenuse, is always across from the right angle. So 10 is going to go in for my c squared where my x was. Okay, because this time I know my hypotenuse. Last time I was finding my hypotenuse. So it's really going to be x squared plus 3 squared is going to equal 10 squared. X squared plus 3 squared is 3 times 3. And 10 squared is 10 times 10. I'm going to use my subtraction property of equality to get x squared plus 0, which is just x squared, equals 91. And again, I don't want x squared. I want just x, so I'm going to unsquare it by square rooting. And my square root cancel out, so I end up with just an x on the left side. On the right side, this isn't what we call a perfect square, which means it's going to give me a decimal. Decimals are okay, that's fine. My answer is going to be 9.539 when I round correctly to 3 places. 9.539. So my distance from E to N equals 9.539 units. Okay, so hopefully this helps you with working with angle bisectors. Your two angles are the same. You can add them together to find the whole angle. Or if you know the whole angle, you can divide it in half to find each side. And then working with your incenters, realizing that the distance to the sides are just radii of those inside circles. So they are going to be congruent to each other. Each of those radiuses will be the same. Okay? If you have any questions, please make sure that you ask during sync time or attend tutoring. Thank you so much for watching. Goodbye.